Hello everybody, I will start my today's coding practice. So today I picked up this question. Design search autocomplete system. Okay, so the question goes like this. So design a search autocomplete system for search engine. Users may input a sentence, at least one word, and end with a special character sharp. You're given a string array sentences and an integer array times, both of strengths n, where sentences I is the previously typed sentence and times I is the corresponding number of times the sentence was typed. For each input character except sharp, returns the top 3 historical hot sentences that have the same prefix as the part of the sentence already typed. Here's the specific rules. Okay. The hot degree for a sentence is defined as the number of times the user typed the exactly same sentence before. Okay, exactly the same sentence before. The return top 3 hot sentences should be sorted by hot degree. The first is the hottest one. If several sentences have the same hot degree, use ASCII code order. Smaller one appears first. So this means that the hot rank, hot frequency are the same. The two sentences should be sorted in a dictionary order. And if less than 3 hot sentences exist, return as many as they can. Okay. When the input is a special character, it means the sentence ends. And in this case, you need to return an empty list. Okay. Implements the Autocomplete system class, which is initiated with list of sentences and times list. Okay. And input method indicates the user types the character C, returns an empty array if C is equal to sharp, and stores the inputted sentence in the system. Returns the top 3 historical hot sentences that have all the same prefix as a part of the sentence already typed. If there are fewer than 3 matches, returns them all. Okay. Quite a long sentence. Quite long description. So that being said, I will take a look at the examples. So example 1. The autocomplete system is initiated with the sentence I love you, Iran, Iron Man, I love LeetCode. And I love you has appeared 5 times. Iran 3 times, Iron Man twice, I love LeetCode twice. And then user types I space A sharp order. And when I is typed, all of them begins with I, so all of them are the possible, suggestions. However, okay, so, and out of them, I will find the pick hottest numbers. Hottest strings. So I love you appeared the most, so I love you is chosen. Then Iron is chosen, Iron Man is chosen. No, and Iron Man and I love LeetCode, they appeared twice for each. So the hot score are the same. So I will sort them in the dictionary order, and then so since like space comes first, so I love read code is the third suggestion. Then and as I can see, input should be space or sharp or lowercase English letters. Okay, then so when I type space, now it I space. So only I love you and I love LeetCode are the possible suggestions, and out of them they are sorted in the hot core. So I love you comes first, and I love you LeetCode comes next. And then I type A. Now the sentence is I space A, and there isn't any string, which is which has I space a as a suffix, so this is empty list. And when sharp is typed, so it should always empty list. So it's the last element is the return that list. Okay, good. So I understand this question. One thing I'm a bit wondering is if I input the string, should it be, registered to this autocomplete system immediately after finished or not? Wait a minute, I have no idea on that. So what I'm wondering is if this autocomplete system is called multiple times. Now each tested sentence will be a sequence of characters C. Yeah. I see. It's a previously typed sentence. Yep. I think I don't have to register the word which is typed in the test cases. And if I have to, then I will update my code after executing the code and it fails. Okay. Then good. Okay. So obviously in this question, I will find the strings which begins with the suffix. So seems like the suffix 3, which is try, will be used. So let me try with that. No pun intended. So, and in this question, probably, one thing I'd like to confirm is if the space can appear in a row, like multiple spaces. No, the words in each input sentence are separated by single spaces. Okay. So that being said, let me think with this example. In this case, I love you is typed, so this should be, wait, then this should be space, then L O V E space Y O U. So this is the first, sentence, and it appears 5 times. So this I love you should have auto score 5. Then the next word which is registered is island. We should look like this. And this is input 3 times, so this should be 3. Then also I will get I love space LeetCode. This should come here. Then this appears twice. Then the last input is, and also Ironman. This should come here. This should appear twice. Okay, so basically this is the try which should be created from the given, initiated words. And what I would do is when the user types, say, I, now the pointer should be here, current pointer should be here, then I will, look for every, string which ends with that. Then when user types I space, then it goes to here. Then I will try to find every, words in later. Then when user types I space and A, actually this isn't in this try, so I can't go down anymore. So I will return empty rest. Then after that I get sharp and immediately empty rest. So all of those lists in the list should be returned. Okay, so the next thing I should do is, let me assume the time complexity for this, because here sentences is up to 100, and I will search up to 3 sentences. So in the worst case, I have to traverse 300. No, it isn't necessarily. Okay, so in total, let's see. If I traverse all the rings, it should be 26 to the power of 100. And including space, it should be 27 to the power of 100. Because for each node, there may be up to 27 child nodes. Then the depth of the tree, height of the tree should be 100 at max. So that's, max number rings which are registered in this try. Okay. But I actually have to find only 3, hottest words. So maybe I can optimize that part to find the top 3 from these, child nodes. Hmm. So but basically that's the idea I will implement. I'm still wondering how I can get the top 3. One possible idea is each node should have the kind of cache for that. And each node should have the top 3 sentences. And instead of storing the sentences of the top 3, each node should have the string whose node represent. Like this node should have IROM string. Then, oh sorry, let me change it to here. Then, if this node is the I mean, this node to count should be stored in this node. So node n, which is 2, and rank is 2. Then from this register hashmap or something, data structure, I can get the reference to this node, and I will, update it. I think this is a possible approach. Okay, but let me first implement this without optimization. Okay, so the first thing I will do is register the given sentence to the try. And for that, I will use the, first I will define the node class. So this char represents the char that this node represent, and its end represent if there is a word which ends with this, string, this character. Oh, and instead of that, I can do it like frequency. So if the frequency is 0, it means that there isn't any string which ends with this node. But if frequency is 1 or more, there is a string which ends with this character. Yeah, and frequency represents the number of those strings. And children has the child nodes. Okay, so I will implement initialize method. Okay, so first three, I will try to register each sentence. And for where should I register these sentences? So definitely I should define the root. So this is a pseudo root. So this is just for the ease of the implementation. And from the direct child of this node, they represent some character. Okay. So for each sentence, so if there is a character, oh sorry, and I'd like to confirm is sentence ranks is 1 or larger. So if char is sharp, then it's the end of the sentence. So current dot frequency divided by 1. So this current is a pointer of the node. And otherwise, I will try to go down. But if char is not in current children, I have to create a node. Oh, sorry. So let me say. Sorry, let me just break here. Then I will register, do that operation here before return. And Then I will move to that node. Okay. So for for the sentence, I use the current as the pointer of the node. Then for each character is a sentence. If the character is sharp, it's the end, so I will break. Otherwise, I will move down to the node, child node of that character. Then, yeah, I will keep it. I will keep doing that. And in the end, I will increment the frequency by 1 for the end node. Okay, so this is the register method. And for input method, oh, I have to remember the current place. So here, this is the current node. So yes, the thing I'd like to do is I'd like to keep the current pointer because this input method is called multiple times. And when the character is typed, what I should do is like this. So, oh, wait a minute. So for C, I'd like to go down to the child node, which represents the given C. I mean, the move's current pointer. So I try to do it. But if the C is not registered in this auto search box, auto search class, then I will return empty arrays immediately. But I have to make sure that, say if user types ABC and the word AC is already registered, when A is typed, I should return AC. But when AB is typed, I should return empty rest. Then ABC, empty rest again. But I have to make sure that if the user types the AC, I don't return AC because I mean I have to make sure that there's no traversal anymore if AB is typed, so that AC wouldn't be handled by the registered AC string. So let me say ended. No suggestion. Suggestion ended. Let me see. Is this in line 50? If suggestion is ended, I will return the empty array. Wait. Yes, correct. And also if C is sharp, also I will return an empty array. Otherwise, I will try to find the child which represents C, and if they redundant, I will mark suggestion ended as true. Then I will return empty rest. Okay. Otherwise, I remove the current pointer. So now it's a self.current. So from here, what I would do is find top 3 words. Probably I can use the heap to guess the top 3 words. I will use this as the... I'd like to guess the top, so I'd like to get it as a mini heap. Wait a minute. 3. So if I try to guess the top 3 words, which means that... Yeah, okay. A bit confusing thing is that I'd like to pop out the smallest hot score, but for the string, I'd like to pop out the later one, larger one. I see. So yeah. So I'm wondering how I can do it. So, if there's so many words with the same score, I don't want to keep all of them in one place. So if I'm given the string, what should I do? One possible way is I will create the string from string, the string score. Yeah. Means I'd try to get the top 3. How should I do? Yeah, so let me... So this returns the list. No, wait a minute. Yep. Score whose, with which, yeah, meets like this. So in this way, here it should be string score minus. So theoretically, in Python, in mini heap, when the hot score is small, it will be popped at first. However, if the store score is large, then it would be popped out first. So that's how it works. Okay. So let me see. So then from here, I will start the backtracking. Then I will return the top speed in a sorted order. No. Like this. Oh, but I have to put the and I will keep the original string here as the third argument. So I will take a look at the third index element, which is the original string. Then I will append it to the returned list, and finally I have to sort it, because now I have to reverse it, because the smallest one comes first. Yeah. Okay. Then what I should do is I will implement the find method. So wait, I have to make sure that what is currently in this list. Yeah. Otherwise, I mean, what characters are already written, typed in the input method call before this call. So this serves the chat software is a global variable. I will use it. So currently I'm at root. Okay, and I will take a look at every character below this root. Then for each char and node, what I should do is I will take a look at the node child. I will keep going. However, I have to make sure is for this root is already registered in the character in the self dot char software, right? Wait a minute. Yeah, yes. So before calling this child method, I have to register it to the child software, like this. Then I will keep going. Then when it comes back from the call method, I will roll back the change I made here in line 64. Is that it? But some case I have to take care is the first case. If root dot frequency is larger than 1 or equal to 1, it means that the registered word is found. So I have to put it in the return array. The found word is like this. Then the frequency should be root of the freq. So I will append, push this into the heap queue. Heap. With string score. So like this. Okay. And I think that's it. Anything I have to take care. So sorry, this should be word string score, and word hop score should be this. Wait, so self.current is old, and this variable self.current will not be updated anymore. But no, it already moved, so it's okay. Good. Then the last thing I will do is implement the toString score method. Let me just think if this is read, okay? If, yeah, frequency is more than 1, I registered it to, oh, and I have to also heap pop. Yeah, if the number nodes in the top 3 is larger than or equal to 4, I have to pop it out. Okay. Good. So I will implement the toString score method. So I will do it in this way. So for each wait a minute. I have to know the length of the string. So AB. No, it doesn't have to necessarily. Let me think of this. And assuming that this A is 1 point, like this. In this case, what I should do is this becomes larger and bigger. But the problem is I don't know how many the ranks of the A, B, C, D, E this string. Oh, sorry, it's okay. All I just have to do is say if I'm given the string, then for each char, I will get the order in this way. And I will do it in this way. Or maybe 20, 30 is good enough. It should be more than 27, which is the number of the characters in, possible characters. Then I will return this score. And with this, if the string is longer, it becomes larger. And if the string has a later character, which has the bigger order, then it should become larger. Yep, so this looks good to me. Okay, so let me, execute my code with this. Oh, so this should be, local function. Top 3 is not defined. Okay, so top 3 should be shared across the, method. I will make it non-local. Wait, what's the problem? Non-binding for non-local top 3 found. Wait, so do I have to do it in this way? I forgot. Okay, so now I remember. So non-local should be defined inside of the function when using this top 3 variable. Like this. Okay. So let me take a look. So it seems like Roman Icebrand. Love you is returned. Completely wrong. Let me see. Oh wait. I forgot something. So in register, I forgot to register the number of times the string appeared. And after finishing this here, I have to append current frequency particular type. Oh, so it's I am the first thing I found from this first result is that firstly I have to somehow get I in the result. Yeah, first I. So this is the typed character. So let me see. When C is typed, I have to append it to the chat software. That's it. So let me. Okay, then I get Ironman instead of I love LeetCode. Probably this is because word score is not correct. So let me check. If the word score is large, then it should come first. Wait, let me quickly confirm. See something. So let me check space versus R. And let me confirm that spaces has smaller orders than R in this way. Yes, small space has smaller order than R, so it should work. Let me check. For each string to the score. So I love you is this. I love LeetCode is Roger. By the way, I think I can cache this method. So when I compare iRoman and I love LeetCode, I love LeetCode is much larger. Wait, this isn't correct. So when I compare iRoman and I love LeetCode, just only last 4 character matters. So it shouldn't insert any long string, right? I can ignore the score which comes from space LeetCode. So that's it. Wait a minute. So maybe I have to know the ranks of this. Okay, for now, let me assume that there are 100 chars in each string. And if the yeah, so I will put the index from 0. digit score. And if there isn't char anymore, this should be 0. And then what I will do is I will add this char score to this. So in this way, score becomes bigger and bigger. No, it's quite large. I don't want to do it. Wait, so how can I guess the string score? Or I should say, how can I use string comparison in the heap? Wait a minute. So okay, so one approach is that hmm. Oh, actually this is accepted. Even though this takes so much time, I guess. So let me execute my code with this for now. Oh, wrong answer. Okay, I will. Actually, I'm not pretty sure. Calculating score versus. I see, but I think calculating score is only done only once. So it wouldn't take that much time, I guess. Let me focus on fixing this bug. So when the input is yes, I love you, eyes round, Ironman, I love LeetCode. In this case, when I love you is type. No. So it types I space A sharp. Oh. So when sharp is typed, it seems like I have to you know, revert this pointer or something like that. So what I should do is if C is sharp, I will return this, but also I have to reset suggestion ended. Also, I have to reset child software. Okay, and also I have to reset self.current. Then I can return it. Okay, and then I will append. Otherwise, I will append this character to child software and continue. Good. So let me execute again. So seems like now my object is here. Wait a minute. I see. So now it seems so I space A should be registered. So that I have to update that. So what I should update is, so in line 57, I thought of the suggestion end. However, I shouldn't. I mean, I have to keep creating some node when the new string is added, right? So what I will do is suggestion ended. I don't need this variable anymore. So instead of thinking of this, in line 56, okay, so in line 59, if C is not in self.children, I will create that node. Then I will go down to that node. And with this being done, I don't have to think suggestion is ended or not. Because if the type string is completely new, like a NEWS new string, like ABCDE, the new node is created as the bottom in the try. And from that, I cannot find any new registered string, so it's okay. But what I have to do is here after the traversal, oh, I have to, append the new word. Wait a minute, so start with current. I see, so that's the case when this is typed. So here, I have to increment the frequency of the current node because it end of the new word. So that's it. Okay, now it's accepted, so I will try again. Let me remove the suggestion ended variable. Okay. So still a wrong answer. Let me check. So in this case, so ABC, I will write it because it's not so big test case. A, B, C is registered and A, B, B, C is also registered. And also only A is registered. This should be 1. This C should be 1. And this BBC. This C should be 1. No, sorry, 333. Then first 3. B is typed and it doesn't have any. but B is now registered. Then next string is C. I cannot find, but C1 is registered now. Okay, then I get sharp, which means that there's no new string. In that case, I don't do anything. Then I get B. Oh wait, that's confusing. So input should be like this and output should be like this. And which one is wrong? I will check. This wrong string is wrong. A, B, C, yeah. So here, it made a mistake. So it seems like obviously I didn't expect sharp itself is not good. So maybe that's why. And what was my return string? A, B, C. So this and this should be opposite. I mean swapped. ABC and ABBC. Seems like it's just a problem with the score. So let me print out the score again. So score of ABC is this, ABBC is this. Seems like ABBC is larger. So this should be popped out first. Oh wait, I think I'm, I see. So in line 98, I reversed them. However, I have to make sure that they're not, so, I mean, with this, the strings are sorted just by the dictionary order of those strings itself. But I have to take care of the rank, hot score. So I should, instead of doing this, I think I should sort it in top 3, just top 3. Then I will return the word in each top of each element in the top 3 tuple. I should return the only word in the tuple which were in the top 3 list. Frequency. So it should be this. So I think I have to reverse this instead of sort. If I reverse this, if the hot score is high, it comes first. If the string score is small, it comes first. Yes. Wait. So this sorting doesn't work yet. Oh, we printed the isn't. Wait, so at least this is sorted by the. No, it's not sorted by the hot score. Wait. Ah, I see. Sorry. I have to sort it and then I have to reverse it. Good. And the problem is here. I will compare ABBC and ABC. The ranks are the same. So, but obviously this part has the problem. Wait, what should I do? So I will sort the top 3. And now hot score first. Yeah, but seems like these are okay, but maybe this failed with this specific reason. I mean 2K3. So when BC is added, probably nothing happens. So let me see. BC, ABC. ABC, ABBC. BC. Okay, so just for this test case, I will change this to 4 because, yeah, the rank is up to 30. No, up to 4. So with this, when I take a look at top 3, when ABC is included, this one. So all of them has the same occurrence 3, which I guess correct. Yes. And then A has the, largest, no, smallest score, ABC next, and ABBC. No, in terms of the score, ABBC, ABC order. Yes, so it should be sorted in that way, but not. So top 3 is already sorted. Oh no, I mean I think just maybe string score method is wrong, I guess. So comparing ABC and ABBC, ABBC should be smaller, but now this is larger. Because I see order of strings should be more than 30. I don't remember this ASCII char. Let me change it to this way. So if this is space, it should be 0. Otherwise, this. So A should be 1 and B should be 2. In this way, all of the char scores should be between 0 to 30. Okay, so let me update this to 100. Get my code again. Good. Now it's accepted. So let me wrap up my today's coding practice. So today I solved the question design search autocomplete system. And basically I used the try for this, just like the typical autocomplete or auto suggestion system. And the hardest part in this question is after registering the try, after registering each sentence into the try, and when I try to find, when the user types AB, like, or maybe IS, or maybe, I space L, after that, I have to find the top 3 words below this 3, below this subtry. So for that, I use the backtracking. However, I don't wanna, I mean, I didn't wanna, I didn't want to visit all the string. No, I actually visited all the strings, but I didn't want to store all the strings into one, yeah. So I didn't want to store all the possible complete strings into the list. So I used the mini heap for that with the size 3. So, and for that string, I didn't have to do the string comparison. So that was the hardest part, and I implemented it in the 2-string score. But aside from that, yeah, I think this is a kind of typical try implementation. And also I have to, because input is called separately so many times, I have to make sure where to keep track of the pointer to the node where current position, of the current position. Yeah. And also when the sharp is typed, I have to register the child software. I mean, the string user has typed into this system. So I increment the frequency by 1 and also reset the current pointer to the root node. Those are things I had to take care. And for the time complexity, firstly, I will give him the birth, and when the space for that is 20 to the power of 100 or NL. If all the strings are different, yeah, it should be n times average L nodes to be used, but it cannot go up more than 20 to 6 to the power of 100 because this is a trie, and same node can be used for multiple births. And also, aside from that, actually, I think this is the best complexity I used. And I use the child software list, but this should be up to n. No, sorry, up to max ranks. Yeah, which is 100. Okay. And for time complexity, so firstly, I have to register each node to the list. Sorry, each sentence to the system, which will take an L. And for register, no, for input, for each, I have to move the pointer by 1. And after that, in the worst case, I have to try to visit all the nodes to find the wrongest string. No, sorry, find the top 3. So it should be up to 26 to the power of 100. Yeah, sorry, this. But again, this can be up to NL. Yeah, I'm thinking of the case when n is small. And yeah, in that case, think of the case when the user types sharp and then I have to traverse all the tree. In that case, again, if the each registered strings are unique, I have to visit n times L, sorry, average L nodes. So it should be the time complexity. And for the heap operation, I can ignore this because the heap length is 3, which is constant. And also, yeah, that's the reason why. Okay. Good. Let me finish my today's coding practice with this. I will just quickly search how I can use string in a mini heap in an easy way. And I probably I will write it in the description of this video. Thank you. See you tomorrow. Bye.